For centuries, humanity has gazed at the night sky, wondering about those twinkling lights. Our ancestors told stories about the stars, navigated by them, and built monuments aligned with them. But looking from Earth has its limits. Our own atmosphere blurs our view. The dream was born, a telescope in space. Astronomer Lyman Spitzer Jr. championed the concept. The Hubble Space Telescope was more than just a machine. It was an ambition to peer deeper into the universe than ever before. In 1990, the Space Shuttle Discovery carried the Hubble Space Telescope into orbit. Its deployment was flawless, but the first images were fuzzy. Hubble's main mirror had a flaw. NASA devised a plan to fix it. Astronauts installed corrective optics during a daring space mission. Hubble was fixed. The universe snapped into sharp focus. It was an incredible comeback story. With its vision corrected, Hubble began its groundbreaking mission, sending back images of unparalleled depth and beauty. We saw swirling galaxies, the birth of stars, and the delicate shells of dying stars. Hubble gave us a new perspective, helping us understand the scale of the universe and measuring cosmic distances. It showed us that our Milky Way is just one of billions of galaxies. The telescope has provided insights into how stars are born, live, and die. Hubble uses spectrographs to analyze light, revealing chemical composition and temperature. It provided evidence for supermassive black holes and has fueled thousands of scientific papers. What makes Hubble's discovery so thrilling? It's the joy of the unexpected. The universe is more inventive than our theories predict. Hubble uncovers phenomena that leave scientists scratching their heads. It reveals new mysteries, pushing the boundaries of our cosmic understanding with every observation. Servicing missions have upgraded its instruments, equipping Hubble with more advanced technology. We're diving into some of Hubble's recent wild discoveries. These are captivating stories of cosmic evolution and the ever-changing nature of the universe. Hubble fuels our curiosity and inspires us to keep exploring. Imagine giant, glittering balls of stars, globular clusters. They're like ancient cities, millions of stars packed closely together. These star cities are incredibly old, some nearly as old as the universe itself, orbiting big galaxies like our Milky Way. They really are beautiful sights full of countless twinkling lights. But within their ancient hearts, secrets hide. For a long time, we thought we had globular clusters all figured out. This was the prevailing wisdom for many years. But the universe loves to challenge our assumptions. What if these sparkling star cities were hiding something darker? Hubble, our eye in the sky, was about to uncover something quite unexpected. To hunt for cosmic secrets, you need a good target. Astronomers chose NGC 6397, one of the closest globular clusters to Earth, making it easier to study. Its dense core is where astronomers wanted to look. Hubble, orbiting above the atmosphere, has incredibly sharp vision. It can distinguish individual stars, crucial for understanding these ancient star systems. For this study, they were likely searching for an intermediate mass black hole. Astronomers observed NGC 6397 over several years, tracking the motions of individual stars. This meticulous data collection held the clues to the mystery within the cluster's heart. As the astronomers analyzed Hubble's data from NGC 6397, they noticed something peculiar. The stars in the cluster's core were moving. That was expected. But they were moving in ways that just didn't quite add up. Some stars were zipping around faster than they should be. It was almost as if they were dancing with invisible partners. Their speeds and paths suggested that there was more gravity at play than could be accounted for by the stars they could actually see. This is a classic cosmic detective story. Follow the motion, and you'll find the mass. This puzzle is what astronomers call the invisible mass problem, or sometimes the missing mass. The visible stars, even the faint ones Hubble could detect, just didn't have enough combined gravity. Their gravitational pull wasn't strong enough to make the other stars move in the observed patterns. So, something else had to be there. Something unseen, yet gravitationally significant. It was hiding in the core of NGC 6397, tugging on the visible stars. The universe was presenting a clear challenge. Figure out what this hidden mass was. Scientists considered several possibilities for this invisible mass. Could it be a concentration of very faint, small stars? Maybe. Or perhaps a collection of neutron stars, which are the super-dense remnants of slightly smaller massive stars than those that form black holes. But when they crunched the numbers, these explanations just didn't quite fit. there wouldn't be enough faint stars or neutron stars to account for all the extra gravity they were detecting. The observed stellar motions required something more substantial, or more concentrated, than these alternatives could provide. The mystery deepened, pushing astronomers to think beyond the usual suspects. The leading theory for a central unseen mass in a globular cluster was an intermediate mass black hole, a single relatively large black hole. But the way the stars were moving didn't quite match that picture either. The gravitational influence seemed more spread out. It wasn't like stars orbiting one dominant central object. It was more like stars moving within a diffuse cloud of invisible mass. This was a crucial clue. The distribution of the unseen matter was key. And as always, the universe loves to keep us guessing. This puzzle was getting more intriguing with each new piece of data. Then came the aha moment. The astronomers realized the invisible mass wasn't one single object. It wasn't a solitary, medium-sized black hole reigning over the cluster's core. Instead, the evidence pointed to something else. The gravitational effects were best explained by a collection of smaller, dark and dense objects. A crowd of them, all clustered together in the heart of NGC 6397. This was a different scenario entirely. It suggested a hidden population, not just a single monarch. The unseen dancers were numerous. What could these smaller, dark objects be? The prime candidates were stellar mass black holes. These are the black holes that form when a very massive star, many times the mass of our Sun, reaches the end of its life. It collapses under its own gravity, creating an object so dense that not even light can escape. Each one would be relatively small compared to an intermediate mass black hole. But if you had enough of them gathered together, their combined gravity would be significant. This started to look like the most plausible explanation for the strange stellar dances Hubble had observed. This discovery was a genuine shock to many astronomers. Remember, the prevailing theory was that globular clusters should have ejected most of their stellar mass black holes. The constant gravitational interactions in such a dense environment were thought to act like a slingshot. Heavier objects, like these black holes, would tend to get flung out into intergalactic space. Finding just a few might be plausible, but discovering a significant concentration of them right in the core? That was unexpected. It challenged the standard models of how these ancient star systems evolve. Hubble's incredibly precise measurements were the key to this discovery. Even though these black holes are, by their very nature, invisible, their gravitational influence is not. Hubble allowed astronomers to track the movements of the visible stars so accurately. By seeing how these stars were being tugged around, scientists could map out the location and estimate the total mass of the unseen objects. It was like detecting ghosts by watching how they disturbed the dust in a room. Hubble didn't see the black holes directly, but it saw their undeniable effect on their stellar neighbors. This surprising finding forced astronomers to rethink some old ideas. If NGC 6397 was home to a hidden cluster of stellar mass black holes, what did that mean? Perhaps globular clusters are actually much better at holding onto their black holes than we previously believed. Maybe they are not so quick to kick them out. This would be a major shift in our understanding. These ancient star cities might be black hole havens, protecting their dark residents for billions of years. The universe, once again, showed us it's more complex than our simple models. So, how could these black holes have stayed put? One possibility is that the process of mass segregation is incredibly efficient. This is where heavier objects in a star system tend to sink towards the center over time. Imagine shaking a box of rocks and sand. The bigger rocks tend to settle at the bottom. In a globular cluster, black holes are among the heaviest objects. They would naturally migrate towards the core. Perhaps, once they get there, they form a stable, tightly bound system that is harder to disrupt and eject. The conditions in the very early universe when these clusters formed might also play a role. This discovery really changes our picture of globular clusters. We used to think of them as relatively quiet places, mostly old, calm stars slowly orbiting each other, almost like stellar retirement homes. But if their cores are full of black holes, that changes everything. Black holes are dynamic objects. They warp space-time. They can interact with each other and with nearby stars. This means the cores of globular clusters could be much more active and violent places than we imagined. They could be sites of intense gravitational encounters. These ancient star systems, therefore, are not just passive relics from the early universe. They are evolving, dynamic environments. They are full of dark secrets and hidden populations. The presence of many black holes suggests ongoing processes and interactions that we are only just beginning to understand. It's a cosmic twist that makes globular clusters even more fascinating. They are not just beautiful to look at, they are laboratories for studying extreme physics and the long-term evolution of stellar systems. The old cities still have new stories to tell. The discovery of a concentration of stellar mass black holes in NGC 6397 has ripples far beyond just understanding globular clusters. It connects to one of the most exciting new fields in astronomy: gravitational wave detection. Observatories like LIGO and Virgo have been detecting ripples in space-time. These ripples are caused by cataclysmic cosmic events, such as the merger of two black holes. If globular clusters are indeed havens for many black holes, they could be prime locations for these mergers to occur. They could be black hole merger factories. Think about it. If you have a dense collection of black holes all orbiting each other in the core of a cluster, they are bound to interact. Sometimes two black holes might get close enough to form a binary pair. Over eons, this pair will radiate gravitational waves, lose energy, and spiral inwards. Eventually, they will merge, creating a bigger black hole and sending out a powerful burst of gravitational waves. The black holes found by Hubble in NGC 6397 could be the progenitors of such events. They represent a previously underestimated source of these cosmic echoes. This finding helps us connect different pieces of the cosmic puzzle. On one hand, Hubble is looking at the subtle movements of stars in a nearby cluster. On the other hand, LIGO and Virgo are detecting gravitational waves from colossal black hole collisions, often from very distant galaxies. This discovery of black hole populations in globular clusters provides a plausible astrophysical setting. It helps explain where some of these merging black holes might be coming from. It links the small-scale dynamics within a star cluster to vast, universe-shaking events. Science is all about making these connections. Hubble continues to be a revolutionary tool. It keeps showing us that the universe is always more complex, more surprising, and more fascinating than we imagine. This discovery of hidden black holes in NGC 6397 is a perfect example. It challenges theories, opens up new avenues of research, and deepens our appreciation for the cosmos. But the story isn't over. Astronomers will use Hubble and other telescopes to search for similar black hole populations in other globular clusters. Each new discovery will help us refine our understanding of these enigmatic objects and their role in the grand cosmic drama. The exploration continues. Imagine a star like our Sun, reaching the end of its life. It gently puffs off its outer layers, forming a glowing planetary nebula. These are some of the most beautiful objects in the night sky. One such jewel is the Stingray Nebula, the youngest known. Scientists could study its earliest stages. Its rapidly evolving central star made it a perfect laboratory to watch a nebula develop in real time. But the universe is full of surprises. The Stingray Nebula wasn't following the expected path. This cosmic butterfly was about to take an unexpected turn. The Hubble Space Telescope began observing the Stingray Nebula in the 1990s. Its first images, taken in 1996, confirmed its youthful nature. These images provided a crucial baseline. In 2016, astronomers pointed Hubble towards the Stingray Nebula once again. But what they saw was startling. The nebula had changed dramatically. It was significantly fainter. The vibrant glow had diminished considerably. This was a rapid decline, happening right before Hubble's unblinking eye. This kind of rapid dimming was unprecedented for a planetary nebula. That was unheard of. Hubble had caught the Stingray Nebula doing something extraordinary. The team analyzing the Hubble data was stunned. One researcher described it as very, very dramatic and very weird, a sentiment echoed by the astronomical community. It's rare to witness such a rapid change in a planetary nebula. To see one deflate in brightness over 20 years is like watching a mountain crumble in a minute. Instead of brightening as expected, it was doing the exact opposite, with astonishing speed. No other planetary nebula had ever been observed to fade so rapidly, challenging existing theories. Astronomers suspected the answer must lie with its central star, SAO 244567. If the nebula is dimming, it implies that the star itself is undergoing rapid changes. The Stingray Nebula's fading light is tied to its central star, SAO 244567. This star's temperature dictates the nebula's glow. A hotter star emits more high-energy ultraviolet radiation, ionizing the surrounding gas and causing it to shine. If the star's radiation decreases, the nebula dims. Astronomers found that SAO 244567 had been rapidly heating up. then surprisingly began cooling down. Scientists theorized the star experienced a late thermal pulse, causing it to briefly reignite helium fusion. This cooling explains why the Stingray Nebula is fading so dramatically. We caught a fleeting moment of glory followed by a rapid decline. The cooling of the central star has direct and visible consequences for the Stingray Nebula. As the star pumps out less ultraviolet radiation, the gas in the nebula begins to recombine. The once vibrant glow starts to fade. The dramatic fading of O3 emission indicates the star is no longer hot enough to maintain this ionization. Beyond just fading, the nebula's structure also appears to be changing. This suggests that as the ionization front recedes, the outer parts of the nebula are returning to a state of neutral, non-glowing gas. The cosmic butterfly's wings are literally dissolving back into the darkness. The Stingray Nebula is teaching us that the on switch for these beautiful objects can sometimes be very temporary. The rapid fading of the Stingray Nebula provides profound insights into stellar evolution. We may have caught its central star in a brief on phase. The universe is constantly performing, and we are lucky to catch some of its shorter acts. The Stingray Nebula's 20-year fade provides an invaluable opportunity to study these processes. This allows scientists to refine their models of how stars die. This underscores the incredible value of long-term monitoring programs with telescopes like Hubble. It allows us to move to a more dynamic movie, capturing change as it happens. Ultimately, the story of the Stingray Nebula is a poignant reminder of the ever-changing nature of the cosmos. Our universe is full of wonders. Some stars are truly colossal. These are the monster stars, giants that dwarf our own sun. Among these giants are the Red Hypergiants. Red tells us about their surface temperature. Hypergiant speaks volumes about their immense size and extraordinary luminosity. These stars are often thousands of times larger than our sun. Their scale means they radiate an enormous amount of energy, making them some of the most luminous stars known. Red hypergiants are very near the end of their dramatic and often violent existence. Red hypergiants are cosmic factories of immense importance. Their demise scatters life-giving elements across the cosmos. Meet VY Canis Majoris, a true giant among red hypergiants and one of the largest stars known in our galaxy. Located about 3,900 light-years away in Canis Major, this star's light began its journey to us during the Bronze Age. If VY Canis Majoris replaced our Sun, its surface would engulf Mercury, Venus, Earth, Mars, the asteroid belt, and even reach beyond Jupiter, possibly close to Saturn. It shines with the power of 300,000 suns, but thick clouds of dust, created by the star itself, hide much of its brilliance from our view. Astronomers have known about this star since 1801, noting its deep red color and dramatic changes in brightness. For years, its true nature was debated. Was it a single star or a system of several stars? What was causing its surrounding nebula? The answer: VY Canis Majoris is a single, unstable red hypergiant, actively shedding its outer layers and creating a vast, complex nebula. Studying this behemoth is a challenge. Its distance and the thick dust make it hard to see details, even with our best telescopes. Its turbulent, extended atmosphere is unlike our Sun's, making it a fascinating but difficult object to understand. Unlocking its secrets pushes the limits of modern astronomy, requiring tools like the Hubble Space Telescope. Imagine if our Sun suddenly dimmed, now multiply that by 300,000. That's what happened with VY Canis Majoris. Over the past century, astronomers have watched this star dramatically fade and recover, sparking questions and concern. Was this the sign of an impending supernova or something else entirely? Red hypergiants are unstable and expected to explode eventually, so any change is a big deal. But was the star itself dying, or was something blocking its light? To solve the mystery, astronomers needed more than just brightness measurements. They needed to see through the dust. Only a telescope with extraordinary vision could reveal what was really happening. Enter the Hubble Space Telescope. Hubble's sharp eyes and infrared vision let astronomers peer through the thick dust around VY Canis Majoris. Using advanced instruments, they analyzed the star's light and its surrounding nebula, searching for clues. Hubble's images revealed vast plumes, arcs, and clumps of material, evidence of violent eruptions from the star. These features weren't evenly spread, but clumpy and irregular, showing the star's chaotic mass loss. Some ejected clouds were found far from the star, moving at incredible speeds. By tracing these clouds, astronomers pieced together the star's turbulent history. The data pointed to a clear hypothesis. Massive clouds of dust, ejected by the star, sometimes drift into our line of sight. When that happens, they block the star's light, causing the dramatic dimming seen from Earth. The star itself isn't fading, it's just hidden behind its own cosmic smokescreen. Hubble's observations brought astronomers closer to solving the mystery. Hubble's data revealed the truth. VY Canis Majoris isn't dying, at least not yet. The dramatic dimming is caused by massive, episodic eruptions of gas and dust, not by the star's core fading. These eruptions fling clouds hundreds of times Earth's mass into space, forming thick dust that blocks the star's light. The process is unpredictable, like stellar-scale volcanic outbursts, and the dust acts as a temporary veil. The star's true brightness remains stable. It's the dust clouds that make it appear to dim from our perspective. This discovery was a relief for astronomers, and it deepened our understanding of how red hypergiants lose mass. VY Canis Majoris will eventually go supernova, but these dimming events are just part of its turbulent final act. Hubble let us witness this process in action, showing how the star is actively shaping its environment. It's a spectacular preview of the chaos that precedes a star's explosive end. The saga of VI Canis Majoris, unraveled by the Hubble Space Telescope, has taught us about the lives of massive stars. Red hypergiants are dynamic systems, constantly churning and ejecting material. These eruptions can alter a star's brightness quickly. They hurl masses equivalent to planets into space, forming nebulae. Mass loss determines a star's fate before it collapses as a supernova. Hubble's observations help refine models of stellar evolution. These models predict how stars live and die. VY Canis Majoris serves as a natural laboratory for studying extreme physics. Future observations will reveal more about these dynamic stars. You know, the universe, our grand cosmic stage, never ceases to amaze. It constantly reminds us that our understanding is really just a work in progress. We build theories, we make predictions, we think we know the rules. Then, a discovery comes along that makes us pause and rethink everything. The hidden cluster of small black holes was one such moment. The Stingray Nebula's rapid fade was another beautiful puzzle. And the monster star's dimming act? Wow, that was a true cosmic surprise. These events show us the universe is just wonderfully unpredictable. These wild discoveries, brought to us by Hubble's keen vision, honestly speak volumes. They paint a picture of a cosmos that is incredibly dynamic. It is not a static, unchanging backdrop to our existence. Instead, it is a place of constant creation, evolution, and transformation. Stars are born, they live dramatic lives, and they die in, well, myriad ways. Nebulae can bloom and fade on timescales we can actually witness. Even the distribution of dark, enigmatic objects like black holes can defy our expectations. The universe is always active, always changing, always full of motion. These surprises are not setbacks for science. They are its very lifeblood. Each unexpected observation, each phenomenon that challenges our models, is a gift. It is an invitation to dig deeper, to ask new questions. It pushes the boundaries of our knowledge further outwards. When we find something weird, like a nebula fading too fast, it's honestly exciting. It means there's more to learn, a new piece of the puzzle to find. This process of discovery, of surprise leading to new understanding, is absolutely thrilling. It keeps science vibrant, ever-evolving, and endlessly fascinating. The universe guards its secrets well, revealing them one glimpse at a time. It doesn't offer simple answers on a silver platter. Hubble, our tireless eye in the sky, helps us peel back the layers. Yet often, what we find beneath one layer is an even more intricate mystery. This is truly the beauty of cosmic exploration. It is a journey without a final destination. The more we learn, the more we realize the vastness of our ignorance. But this doesn't discourage us. It actually fuels our curiosity even more. The universe is a theater of perpetual surprise, and the show is, well, just magnificent. The Hubble Space Telescope is more than just a machine. It's, a testament to human ambition and our relentless quest for knowledge. For over 3 decades, it has orbited above our world. Its unblinking eye has peered into the deepest recesses of space and time. Its longevity is remarkable, honestly, a result of ingenious design and daring servicing missions. These upgrades have kept it at the forefront of astronomical research. Hubble has seen the universe evolve, capturing changes over human timescales. This steady gaze has been crucial for uncovering these unexpected wonders. Hubble has become a true icon, a household name across the globe. Its breathtaking images have not only fueled scientific papers by the thousand, but they've also touched the hearts and minds of people everywhere. It brought the distant cosmos into our living rooms, onto our screens. The pillars of creation, distant galaxies, colorful nebulae, these are now familiar sights. Hubble transformed abstract astronomical concepts into tangible, visible beauty. It has inspired countless individuals to look up and wonder. Its legacy is woven into the fabric of our modern understanding of the universe. Consider its role in the discoveries we've explored. For the hidden black holes, Hubble's sharp vision was indispensable. It resolved individual stars in the dense core of NGC 6397. This allowed astronomers to track their subtle movements, revealing the unseen mass. For the Stingray Nebula, Hubble's long-term monitoring was key. Comparing images taken decades apart showed the dramatic, unprecedented fading. And for the monster star, Voi Canis Majoris, Hubble's ability to see through dust was vital. It mapped the ejected clouds, solving the mystery of its great dimming. Hubble's journey is far from over. Its legacy continues to grow. Even as new powerful telescopes like the James Webb Space Telescope begin their work, Hubble remains unique. It offers a different perspective, particularly in visible and ultraviolet light. Its vast archive of data is a treasure trove for future research. It continues to make new observations, finding new puzzles to solve. Hubble's enduring gaze ensures that our understanding of the cosmos will keep expanding. It stands as a shining example of what humanity can achieve when we reach for the stars. Its light, both literal and metaphorical, will shine on for generations. Let's bring these incredible discoveries together, these cosmic tales. The cluster of small black holes in NGC 6397 changes our view of globular clusters. These ancient star cities might be active nurseries for black hole mergers. These mergers could be the source of gravitational waves we now detect. The Stingray Nebula's rapid fade shows stellar evolution can be surprisingly swift. A star's final stages can unfold in fleeting, dramatic episodes. We were lucky to witness such a rare, fast-paced cosmic event. It reminds us that even celestial beauty can be ephemeral. Then there's the monster star, Voi Canis Majoris, and its puzzling dimming. Hubble showed us it wasn't dying, but rather throwing colossal tantrums. It ejects massive clouds of dust, which then block its light. This provides crucial insight into how the most massive stars lose mass. This mass loss enriches the galaxy with heavy elements, the stuff of future stars and planets. So these seemingly disparate discoveries are, in fact, interconnected. They all tell us something fundamental about the life and death of stars. They reveal the processes that shape our universe and make it habitable. These findings also highlight the sheer diversity of the cosmos. There isn't just one way for a star to die, or one type of black hole. The universe is incredibly creative in its expressions, from the silent gravitational influence of hidden black hole clusters, to the delicate fading light of a young nebula caught in a brief moment of glory, to the explosive outbursts of a hypergiant star shrouded in its own dust. Each discovery adds a new character, a new plot twist to the grand cosmic story, a story that Hubble helps us read, one amazing page at a time. What these discoveries teach us is that the universe is a place of constant learning. We are detectives, piecing together clues from light years away. Hubble provides the crucial evidence, the sharp images, the detailed spectra. It allows us to test our theories, to confirm some, to discard others. The universe is more complex and more wondrous than we can often imagine. The cluster of black holes, the fading nebula, the dimming giant, these are not just isolated oddities, they are windows. Windows into the fundamental workings of our vast and awe-inspiring cosmos. Why do we dedicate so much effort to peering into the distant universe? Why build magnificent instruments like the Hubble Space Telescope? The answer lies deep within the human spirit, our innate curiosity. We are born explorers, driven by a fundamental need to understand. We want to know where we came from, what our place is in this vast cosmos. These discoveries, the hidden black holes, the fading nebula, the monster star, feed that hunger. They provide glimpses into the grand cosmic drama unfolding around us. They connect us to something far larger and older than ourselves. The pursuit of this knowledge is not just an intellectual exercise. It is a source of profound inspiration, a beacon that lights our way. Hubble's images and the stories behind them spark wonder in people of all ages. They can ignite a passion for science, technology, engineering, and mathematics in young minds. Imagine a child seeing the pillars of creation for the first time, or learning about a star so big it would engulf our solar system. These moments can change lives, inspiring the next generation of explorers and innovators. Space exploration lifts our gaze from the everyday and shows us what's possible. Exploring the universe also teaches us humility. The more we learn about its immense scale, its incredible power, its deep mysteries, the more we realize how much we still don't know. The cosmos is vast beyond comprehension, ancient beyond imagining. Our Earth is a tiny, precious oasis in an enormous cosmic ocean. This perspective can foster a greater appreciation for our planet and for each other. It reminds us that we are all crew members on this pale blue dot. The universe is a humbling and therefore enlightening teacher. This unquenchable thirst for understanding drives us forward. It pushes us to build better tools, to ask harder questions. It encourages international collaboration, as the challenges are often too big for one nation alone. The quest to understand the universe is a unifying endeavor for humanity. It transcends borders, cultures, and generations. Hubble's discoveries are not just scientific achievements, they are human achievements. They represent our collective desire to reach out, to learn, and to grow. And that journey, that endless quest, is what makes us truly human. The incredible discoveries we've journeyed through are not final chapters. They are not the end of the story, but rather exciting new beginnings. The cluster of small black holes in NGC 6397 opens new avenues. Astronomers will now search for similar populations in other globular clusters. The fading light of the Stingray Nebula prompts further study. How many other young nebulae might experience such rapid, fleeting phases? And the dimming of VY Canis Majoris? It helps refine models of massive star evolution. Each answer uncovered by Hubble elegantly blossoms into a dozen new questions. Hubble itself continues its vital mission, a seasoned explorer still full of vigor. It now works alongside new observatories like the James Webb Space Telescope. JWST, with its powerful infrared vision, can peer even deeper into dusty regions. It can see the very first stars and galaxies beginning to shine. But Hubble's unique capabilities in visible and ultraviolet light remain crucial. Together, these great observatories offer a more complete view of the cosmos. They are partners in discovery, each contributing its unique strengths. The future of astronomy is bright, with multiple eyes on the universe. What other astonishing secrets does the universe hold in store for us? What new phenomena are waiting just beyond the reach of our current understanding? The prospect is exhilarating. Perhaps we'll find unexpected forms of matter, or witness events that challenge the very laws of physics as we know them. The universe is a treasure chest of wonders, and we've only just begun to explore its depths. The excitement of the unknown is a powerful motivator. It keeps astronomers pointing their telescopes towards the heavens, night after night. It fuels the dreams of engineers designing the next generation of instruments. Our journey to understand the cosmos is a grand, ongoing adventure. It is a testament to the power of human ingenuity and our persistent curiosity. The legacy of the Hubble Space Telescope is not just in the images it has captured, it's in the questions it has inspired, the paradigms it has shifted, it's in the way it has connected humanity to the universe. So, let us continue to look up, to wonder, to explore. The universe awaits, full of mysteries yet to be unveiled, and the journey of discovery, as Hubble has shown us, is its own reward.